Hi guys, there was another question from section 3.1. Problem number 25. So this is actually the same question as the last video. I think it was number 29 I just posted. But this one actually is just a different function, but the same question. We do want to look for the critical values if there are any, and also look for the relative maximum or minimum if there are any. And by the way, not every function has to have critical values, nor every function must have local max relative max or relative minimum, okay? But if they are there, we're going to have to find them. So again, as you know, of course, everything depends on derivative. So we start with d prime. 5, of course, is a constant. Derivative of constant is 0. And this is going to be a chain rule, a function to a power. So I'm sure, as you remember, the rule said the power times the function itself, which is x minus 2, and then times the power minus 1, 2/3 minus 1, which of course becomes minus 1/3, right? And remember, derivative, and then times the derivative of the function, which of course, the derivative of x minus 1 is just 1. I'm going to put the 1 anyway, so you won't forget. Always remember to multiply by derivative of function, which is what chain rule says. So this is your derivative. Now we're going to rewrite it so you can see it better. So remember, there are two types of critical values, right? Where either derivative is 0, and then also where derivative is undefined. So in this case, as you can see, as you rewrite this, I'm going to move the x minus 2 to the negative 1/3 downstairs to make it a positive power. And also, if you want to write it as a radical or cube root instead of 1/3, it's the same thing. Whichever way is easier for you to look at. As you remember from algebra, anything to 1/3 means a cube root of the same expression. So as you can see, this fraction, of course, which is our derivative, can never be 0 because the fraction can only be 0 if the numerator is 0. Of course, here the numerator is 2. So the only type of critical values you're going to get is where this is undefined. Of course, when is a fraction undefined? When the bottom is 0. And of course, when is the bottom 0? When this expression becomes 0, because cube root of 0 is 0. And of course, this only becomes 0 when x is 2, right? Because 2 minus 2 becomes 0, and cube root of 0 is 0. Okay, so in this case, we do have x equals to 2 is our critical value. I'm just going to put CV for critical value, okay? Again, why is this a critical value? Because remember, in your section, I'm sure if you read it carefully, it tells you there are two types of critical values. One that makes the derivative 0. I think in our last couple of examples, we did find those. Also, for some function, if the derivative is undefined somewhere, that's also a critical value. And in this case, this derivative is undefined at 2 because when you put 2 in place of x, of course, that becomes 0. And of course, in math, you can't divide by 0. So we do have a critical value. So the last question, of course, I'm going to leave the derivative here, right there. So because we're going to need that. I think this is probably the easiest form to look at. So I'm just going to go ahead and put our d prime here. Okay, so now we want to know, are there any relative maximum minimum? So again, to do that, this was part A. For part B, as always, we split the number line at the critical value. In this case, this is 2. So to the left of 2, we can take 0. So let's go. By the way, don't forget, this is all about the sign of derivative. So we're going to plug in z. This 0 is going to be our first test value, which is to the left of 2. So as you plug in 0 in place of x, that simply becomes 2/3 times cube root of 0 minus 2, which, by the way, is the same thing as just negative 2. So all of you remember from your, I'm sure, basic college algebra course that a cube root of any negative number. By the way, you don't need to know the exact value. I mean, you could plug it in. All you care to know is if it's positive or negative. Remember, because the sign of derivative is what we're after. The exact value for this doesn't matter. And, you know, cube root of any negative number will remain negative. So, of course, 3 times negative number is still negative. And 2 divided by negative number is also negative, okay? So in this case, we do have an expression that is less than 0, right? So it is negative. So we do know our derivative is negative on that part. Now to see the sign of derivative on the other side of 2, of course, we can take 3, which, by the way, in this case, will be a very good choice anyway, because as you can plug it into our derivative, we do get something that is easily computed. But you can take any real number that is larger than 2. But 3 would be definitely my choice. So d prime of 3, simply, don't forget, this was our d prime, the derivative. I'm just going to replace the x with 3. So that becomes 2/3 times cube root of 3 minus 2. Now, of course, 3 minus 2 is 1. And as you know, cube root or any root of 1 is still 1. And of course, 3 times 1 is 3, which is 2/3. So 2/3 pretty much becomes your d prime of 3, which is positive, of course, number. Because remember, all you really care to see the sign, which is plus or minus. Okay, so now we have decreasing to the left, increasing to the right. So we do have a relative minimum at 2. So all we got to do now is find the exact value. So I'm going to go ahead and take this off. So at 2, we do have a relative minimum. So this is for part B again, relative minimum at the x coordinate 2. Now the y coordinate, this is the only time by the you go to original function, right? So we're done with the derivative. Now I'm just going to put d of 2, which is the value of the function at 2, which is your y value. Now all we have to do is find d of 2. So I'm just going to go under here, compute d of 2. So remember, this is where you go to original function d, replace all the x's with 2, which becomes 2 minus 2 to the 2/3 plus 5. Of course, 2 minus 2 is 0. 0 to any power is 0. And 0 plus 5 becomes 5. So your actual minimum, relative minimum, is going to be the order per 2, comma, fd of 2, which we found to be 5. So the order per 2, comma 5 is your relative minimum. Okay? I hope that helps.